you ever wondered why Java insists that you declare whether a variable is an int or a double? It's not just a quirky rule, it's all about memory efficiency. By specifying the type, Java knows exactly how much space to reserve and how to handle your data. This means your programs run faster and use less memory, which is crucial for everything from mobile apps to massive enterprise systems. Today, we'll break down the logic behind Java's data types so you can write code that's both efficient and reliable. Let's dive in and see how choosing the right type can make all the difference. You write code, every variable you create takes up space in your computer's memory. Java's strict typing system helps the language manage the space efficiently. For example, an int uses 4 bytes while a double uses 8. By telling Java exactly what you need, you avoid wasting memory and prevent errors that can crash your program. This is especially important in large applications, where memory leaks or inefficient usage can lead to serious performance issues. Understanding why Java enforces data types is the first step to mastering efficient programming. Java has 8 primitive data types, but instead of memorizing them alphabetically, it's smarter to group them by size. This makes it easier to pick the right one for your needs. The smallest are byte and short, which are great for saving space when you don't need large numbers. Next are int and long, which handle bigger values. For decimals, you have float and double, with double offering more precision. Finally, char stores single characters, and boolean is for true-false value. Grouping by size helps you quickly decide which type fits your data best. Start with the smallest, byte and short. A byte uses just 1 byte of memory and can store values from -128 to 127. It's perfect for things like file processing or when you're working with large arrays of small numbers. Short is slightly bigger, using 2 bytes and storing values from -32,768 to 32,767. These types are rarely used in everyday coding, but they're invaluable when memory is tight or performance is critical. Knowing when to use them can make your code lean and efficient. Most of the time you'll use or long for numbers. Is the default for whole numbers, using 4 bytes and handling values from about -2 billion to 2 billion. Long is for even bigger numbers, using 8 bytes. If you're counting items, tracking IDs, or working with large datasets, these types are your go-to. They strike a balance between memory use and the ability to store large values, which is why they're so common in Java programming. You need to work with decimals. Java offers float and double. Float uses 4 bytes and is good for saving memory when you don't need a lot of precision. Double, on the other hand, uses 8 bytes and is the standard for most decimal calculations because it's more precise. If you're dealing with scientific data, financial calculations, or anything where accuracy matters, double is usually the safer bet. Understanding the trade-off between memory and precision helps you choose wisely. Char and boolean are the last two primitives. Char stores a single character like A or Z and uses 2 bytes. It's useful for handling text one letter at a time. Boolean is even simpler. It only stores true or false using just 1 bit, though it often takes a byte in memory. These types are essential for controlling program flow and working with text. By understanding their roles, you can write cleaner, more efficient code. Now let's talk about the big picture. Primitive versus reference types. Primitives like int and double store actual values directly in the stack, making them fast and efficient. Reference types such as string or arrays store a reference or address in the stack, but the actual data lives in the heap. This difference affects speed, memory use, and how your data behaves. Understanding this distinction is key to writing robust Java code and avoiding common pitfalls. Stack is where Java stores primitive values and the references to objects. It's fast and automatically managed, which means variables disappear when they go out of scope. The heap, on the other hand, is where the actual objects live. It's larger but slower, and Java's garbage collector cleans it up when objects are no longer needed. Knowing how stack and heap work helps you understand why some operations are faster than others, and why memory leaks can happen if you're not careful. Imagine a diagram. On one side you have the stack, filled with primitive values like numbers and booleans. On the other, the heap holds complex objects like strings and arrays. The stack is all about speed and direct access, while the heap is about flexibility in storing larger, more complex data. This visual distinction helps you remember where your data lives and why it matters for performance and reliability. Reference types are everywhere in Java. Whenever you create an object like a string, an array, or a custom class, you're working with references. The variable holds a memory address, not the actual data. This means you can have multiple variables pointing to the same object, which is powerful but can also lead to bugs if you're not careful. Understanding how references work is essential for managing complex data structures and avoiding unexpected behavior. Primitives are the backbone of Java's performance. Because they store values directly in the stack, accessing and modifying them is lightning fast. There's no overhead of looking up an address or managing complex memory. This simplicity is why primitives are used for basic data and calculations. When you need speed and predictability, primitives are your best friend. Reference types offer flexibility that primitives can't match. You can create objects of any size, store collections of data, and build complex structures. However, this comes with a trade-off. Accessing data is a bit slower, and you have to be mindful of memory management. Still, reference types are what make Java powerful for building real-world applications, from web servers to mobile apps. Strings are one of the most commonly used reference types in Java. Even though they look simple, they're actually objects stored in the heap. When you write string s equals hello, you're creating a reference to a string object. This allows Java to optimize memory by reusing common strings, but it also means you need to understand how references work to avoid bugs. Java uses a special area called the string pool to store literal strings. When you assign string s equals hello, Java checks if hello already exists in the pool. If it does, your variable points to the existing object, saving memory. This is why strings are so efficient, but it also leads to some tricky behavior when comparing strings or creating new ones. Here's a classic interview question. What's the difference between string s equals hello and string s equals new string hello? The first uses the string pool, so if hello already exists, it's reused. The second always creates a new object in the heap, even if the value is the same. This subtle difference can affect memory use and how your code behaves when comparing strings. When you compare strings in Java, using equals equals checks if the references are the same, not the actual content. That means two strings with the same value might not be equal if they're different objects. To compare the actual text, always use the equals method. This is a common source of bugs, especially for beginners, so keep it in mind whenever you work with strings. Reference types are powerful, but they require careful handling. Because multiple variables can point to the same object, changes made through one variable affect all others. This can be useful for sharing data, but it can also lead to unexpected results if you're not paying attention. Understanding how references work is key to writing safe, predictable code. Java's garbage collector automatically frees up memory when objects are no longer referenced. This means you don't have to manually manage memory, but you do need to understand how references work. If you accidentally keep a reference to an object, it won't be collected, leading to memory leaks. Properly managing references ensures your programs stay efficient and bug-free. So how do you pick the right data type? Start by considering the size of the data you need to store. Use the smallest type that fits your values to save memory. For numbers, pick between byte short, int, or long. For decimals, choose float or double based on the precision you need. For text, use char or string. And always remember the difference between primitives and references to avoid surprises. Common mistake is using a type that's too large for your needs, wasting memory. Another is confusing primitives with reference types, leading to bugs when comparing values or managing memory. Always double-check your type choices and understand how they affect your program's behavior. This attention to detail will help you write better, more efficient code. Java's type system is designed to catch errors at compile time before your code even runs. This type safety prevents many common bugs like assigning a string to a number or vice versa. By understanding and respecting Java's type rules, you can write code that's more reliable and easier to maintain. Choosing the right data type isn't just about memory, it also affects performance. Primitives are faster because they're stored directly in the stack, while reference types involve extra steps to access data in the heap. For performance-critical code, always prefer primitives when possible. This can make a noticeable difference in speed, especially in loops or large-scale applications. Reference types are essential when you need to store complex data collections or objects that can change over time. Use them for things like lists, maps, and custom classes. They offer flexibility and power, but require careful management to avoid memory leaks and bugs. Knowing when to use reference types versus primitives is a key skill for any Java developer. Even though arrays look like simple lists of values, they're actually reference types in Java. When you create an array, you're creating an object in the heap, and your variable holds a reference to it. This means arrays can be shared, resized, and manipulated just like any other object. Understanding this helps you avoid surprises when working with collections of data. Some reference types like string are immutable. Once created, they can't be changed. Others, like arrays or custom objects, are mutable and can be modified. This distinction affects how you use and share data in your programs. Immutable types are safer for sharing, while mutable types require more care to avoid unintended changes. Sometimes you need to convert one type to another, like turning an int into a double or a string into a number. Java provides rules and methods for type conversion, but you need to be careful. Automatic conversions can sometimes lose data or cause errors. Understanding how and when to convert types is essential for writing flexible, bug-free code. Now that you understand Java's data types, you're ready to learn about typecasting, changing one type into another. This is a crucial skill for handling real-world data where you often need to move between types. In the next video, we'll dive deep into typecasting, showing you how to do it safely and efficiently. To wrap up, remember, Java's data types are all about memory efficiency and program safety. Primitives are fast and simple, while reference types offer flexibility. Always choose the smallest type that fits your needs and understand how stack and heap memory work. Mastering these basics sets you up for success in Java programming. Ready to take your skills further? The next step is mastering typecasting, how to safely change between data types in Java. This is essential for handling real-world data and building robust applications. Stay tuned for our next video, where we'll break down everything you need to know about typecasting with clear examples and expert tips.